Hello everyone, I am Sai from CSIT. Today in this presentation I am going to explain about quantum computing and code breaking beyond. Let's start with the overview of this presentation. I will start with introduction and history about the classical computers, quantum computers, followed by data representation, conclusion and scope. Evolution of classical computers. First generation 1939 to 54 are vacuum tubes. Second generation 1954 to 59 are transistor types. Third generation 1959 to 71 are IC. The fourth generation 1971 to 1991 are microprocessor computers. The fifth generation 1991 and beyond is considered as fifth generation. Comment on classical computer. Gordon Moore, the Intel co-founder, said that the number of transistors economically crammed into a single computer chip was doubling every 2 years. Functions of classical computers. Accurate and speedy computation machine. Part of life because logical work can also be done. Advantages of classical computer. Any complex computation or logical work like library work become easy. Many kinds of numerical problems cannot be solved using conventional computers. For example, factorization of a number. The computer time required to factor an integer containing n digits is believed to increase exponentially with n. Concepts of quantum computers. Introduction and history. Basic concept of quantum computer. Applications, advantages, disadvantages and problems, and future work. Let's start with introduction. What does quantum mean? The word quantum in a quantum computer originates from quantum mechanics, a basic theory in physics. In brief, on scale of atoms and molecules, the matter behaves in a quantum manner. What is quantum computer? A quantum computer is a machine that performs calculations based on the laws of quantum mechanics, which is the behavior of particles at subatomic level. Let's talk about the history. In 1918, Max Planck's energy quantum. In 1921, Einstein's discovery of photon. In 1980, the idea of quantum computation. In 1996, Grovers came up with an algorithm to search a name in unsorted database. Grover's algorithm and the law of superpositioning makes this possible. In December of last year, Anton Zeilinger made a fantastic accomplishment. This feat was achieved using a principle called quantum entanglement. The basic concept of quantum computers and differences with existing computers. In existing computers, all information is expressed in terms of zeros and ones, and the entity that carries such information is called a bit. A bit can be in either a 0 or 1, a state at any moment in one time. Quantum computer on the other hand uses a quantum bit or qubit instead of a bit. A qubit also makes use of two states 0 and 1 to hold information, but in contrast to a bit, in this state the qubit can take on the properties of zeros and ones simultaneously at one moment. Accordingly, two qubits in this state can be expressed as four values of 0, 0, 0, 1, 1, 0 and 1, 1 all at one time. Here you can see how a quantum computer works and working of a quantum computers towards the realization of a dream quantum computer. What is different about quantum computers? Let's talk about the applications of quantum computers. There is much that is different between quantum computers and classical computers, but I am going to explain only few. Quantum superpositioning, quantum entanglement, quantum teleportation. Let's talk about quantum superposition. Superpositioning is a big word for an old concept that two things can overlap each other without interfacing with each other. In classical computers, electrons cannot occupy the same space at the same time, but as waves they can. One may think of this as a vector of the probabilities drawn into a two-dimensional coordinate system of the complex plane, that is, coordinates of the form x plus iy, where x is a coordinate on the real number line and y is the coordinate on the imaginary number line. Classical bits are either vectors of 0 and or 1 and have no imaginary component. Quantum bits or qubits have both components. If the probabilities were equal, the vector could be represented as 45 degrees from vertical. If the probability of 1 were twice than that of 0, the vector could be represented as 30 degrees from the vertical. This vector represents the superposition of the probability of 1 and the probability of 0 simultaneously. In this way, the state vectors of classical bits are collapse qubit state vectors. Let's see how the superposition state working in a quantum computer. Video 2. Let's talk about quantum entanglement. Entanglement is the ability of quantum systems to exhibit correlations between states with a superposition. Quantum entanglement is one of the central principles of quantum physics, though it is highly misunderstood. In short, quantum entanglement means that multiple particles are linked together in such a way that the measurement of particles' quantum state determines the possible quantum states of the other particles. When this happens, the state of the two particles is said to be entangled. Let's talk about the quantum teleportation. Quantum teleportation is a technique used to transfer information on a quantum level, usually from one particle to another. Its distinguishing feature is that it can transmit the information present in a quantum superposition, useful for quantum communication and computation. Let's talk about the applications of quantum computers. It will provide encrypting technology. It is ultra secure and super dense communications, improved error correction and error detection, the molecular simulations. It is the true randomness which measures the accuracy more than the computers nowadays, and cryptography, searching, factorization, simulating, encryption problem and quantum chemistry problem. Advantages of quantum computers could be process massive amount of complex data than the computers we are using now. It has the ability to solve scientific and commercial problems to the great extent as we never imagined. It can process data in much faster speed than the usual computers. It has capability to convey more accurate answers. More can be computed in very less time. These are used to protect secure web pages, encrypted mail, and many other types of data. Disadvantages of these types of computers: they are very hard to control quantum particles and they will produce lots of heat, and definitely they will be more expensive, and it is difficult to build. It is not suitable for word processing and email. Problem of it: need of a noise free and cool environment, complex hardware schemes like superconductors. Future work: silicon quantum computer, it may become the technology sooner than we expect. At the current rate of chip miniaturization, energy efficiency, and economics, the classical computer of the year 2020, if it could happen at all, would contain a CPU running at 40 GHz or 40,000 MHz with a 160 GB or 1,60,000 MB RAM and runs on 40 watts of power. New algorithms and communication, maximum exploitation, simulate other quantum systems. Let's conclude with a scope. It's a very advanced technology, very fast and powerful. Stage of infancy. Implementation is very difficult. So thank you everyone for giving me this opportunity. Thank you. This is the end of this tech talk.